Hi there, welcome to my example problem. This is part 3 of the 3-part series of transformation. I really want to take my time on this one, so the entire video is going to be dedicated around this particular problem right here. I came up with that problem. I tried my best to make it really bad, and that's by using all fractions, having a number in front of x, making sure that there are two negatives, and then it's just a mess. So it looks kind of funky right there because I had to do it on PowerPoint, but I wrote it again right here. And I called it m of x. Not everything has to be f of x. We don't have to stick to one letter and just keep using it. Anyway, so m of x equals 3 over 7, and then in parentheses negative 3 over 4x minus 1/4 cubed, and that stuff is cubed. And then minus 13. So I'm looking at this and I can see that there's going to be several shifts happening, and let's use different colors to indicate them. We have a horizontal shift, and we have a vertical. Sorry, that's a vertical shift. We have a vertical shift, and we have a horizontal shift right here. So I might as well just circle it. Oh, I don't do that. So let's get started. Let's start with the shifts first. Let's do this shift right here. You can see how I have 13 over 3. So why don't I just go ahead and do this? Let's do this. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and let's stop right there. And let's let's make it 14 because this first one's way too big. So this right here is 13 right there. Instead of calling it 13, let's call each one of these 1/3, meaning that in reality, this is. I wish I was faster at this. Oh wow, that's way too. Let's calm down with the size, huh? All right, let's go ahead and call this one 1, and then every 3 of them. So 1/3, 2/3, 2, and then 1/3, 2/3, 3, 1/3, 2/3, 4, 1/3, 2/3. So 4 and 2/3. That's where we are. That's pretty much where we are right here. Alrighty, so we are moving down to 1/3, by the way. 4 and 1/3. Remember, this is 14, not 13. So this is taking care of this guy, and then we kind of create this imaginary axis. So let's create this imaginary axis along this way. Bam. There we go. So this is our imaginary axis. I'm gonna just call it I don't know, x prime, right? So where this is the x-axis, that's the y-axis, that's my x prime. Now to move this thing vertically, we're going to have this. It's going to be a little bit of a tough one, moving it horizontally, because there's a number in front of x, and the horizontal shift is not necessarily 1/4 to the right. We first have to make sure that there's nothing in front of x. So let's factor out. So right above the term, I'm going to factor out. So this is 3 over 7, right? This didn't change, right? But inside the parenthesis, let's factor out a negative 3 over 4. And then inside we're going to be left with x, because we're factoring this guy out of there. And then when we factor negative 3/4 out of this guy, right? Pretty much what do I multiply to this one to get this guy? And it would end up being positive 1 over 3. Because look at this. 3 times 1 over 3 would just be 1, and then 1/4 times that's just 1/4. So if we multiply 3 over 4 by 1/3, you can see how the 3's would cancel, right? So you would be left with negative 1/4. So that's that, and then minus 13 over 3. Now let's go a little bit further. Let's go ahead and also take this guy, cube it, because it's within the cube property, within the cube exponent. When you use properties of exponents, you know you're supposed to apply the 3 to both of them. we cube this guy, and then again multiply to this one. So this is going to be a huge fraction that we have to deal with, and I just don't know where to put it. Let's use a different color again. Let's go with, I don't know, I like green. Let's make the screen more green. Yeah, there we go. So we have our new function, and it's the same function. I'm just kind of making it look nicer. But instead of having this negative 1/3 there, let's have negative 3 over 4. Let's have negative 3 over 4 cubed. So pretty much what that is we're gonna have a negative. Let's pull the negative out. Because the negative is being cubed, it's still negative, because negative times negative times negative is negative. We had this 3, but we also have 3 of these 3's because that's being cubed. So that is 3 to the 4, right? And then we have 7 on the bottom. We have a 7 from right here, and that's being multiplied by 4 cubed. That's being multiplied by 4 to the 3 power. I'm having difficulties writing 3's. And my last video, actually, I didn't even know how to write 3 the correct way. I don't know how trustworthy my videos can possibly be if I can't even get that right. Anyways, and then inside we have something that looks way better again, because that is x plus 1/3, and then to the cube power. And then we had that minus 13 over 3, which we took care of right there. Minus 13 over 3. There we go. Here's on minus 13. Anyways, here we are. This is an easy fix. That's an easy, very easy horizontal shift. Again, just like I did before, let's have one thing that represents 1. So this represents 1. So that represents negative 1. And let's say this represents negative 1. And just like on these ones, I have these sub-intervals. So cutting it in intervals of 3. So I was using Boo before. So let's say this is 1/3. That is 2/3. And then that will be 3/3, which represents 1. Just like we have right here. So we are moving to the right or to the left. Let's see. That's a positive 1/3, so we're moving to the left. So same thing would need to be done right there. So this is 1/3, and over here we have 2/3, and then this is 1 right there. So we're moving 1/3 to the left. So our imaginary axis would be right through here. So let's move downwards. I should always just have one video on one difficult problem. That way people are not getting, because I see too many students get frustrated and scared, to be honest. Like, they see a problem that looks a little bit difficult and they get so scared they don't even want to attempt it. And I'm okay if a student gets something wrong. I mean, that happens, you know. But if a student doesn't attempt it and I don't see any work, then it's kind of weird, because they get into the defensive mode. They say, oh, but I didn't know how to do it. You shouldn't take any points off. But you know what? You should have tried it. That was my requirement, you know. Anyways, that's it. We pretty much took care of this guy because we moved downwards. We took care of this guy, right? Because we moved to the left 1/3. So really all we have left is negative 3 to the 4 over 7 times 4 cubed times x cubed. We took care of the 1/3. I don't need to write that down anymore. We took care of this guy. I don't need to write that down anymore. I know that there's going to be a flip because of the negative, and I know I'm going to stretch it vertically. The only question I have, am I going to stretch it or am I going to compress it vertically? Is this going to be stretch or compressed? In the last video, you know that you stretch if this is bigger than 1. You compress if this is smaller than 1. So if I did a parent function, if I did a parent graph that represents what's supposed to look normally, meaning it's going to be something like this. So this is my parent graph, right? So all you really have to do is show the parent graph, and then right next, like right there, show me whether you're going to make it vertically larger or smaller, right? So I just have to figure out, this is bigger than 1 or less than 1. I know that this is going to be less than 1, and here's why. This fraction is the same thing as saying 3 times 3 times 3 times 3. So 3 3's multiplied together. And then on bottom I have 7 times 4 times 4 and then times 4. Every single number on the denominator is larger than any number on the numerator. So the denominator has to be bigger. You can verify with the calculator, but I know the denominator is bigger. So when you have a denominator that's bigger, we imply that that has to be less than 1. Has to. So is this going to look like this? Or is it going to look wide? Is it going to look fat or is it going to be skinny? That's the question. Well, since it's less than 1, it's going to be very fat, right? Not very fat. Depends on how much less than 1 it is. The closer you are to 0, the fat it gets. If it is 0, if it was really close to 0, it would kind of look like this, you know. But that's besides the point. Also, do not forget that we did some shifting. So this is our parent graph. Let's make sure that we also move our parent graph appropriately, which I totally forgot to do, and I totally do not have to remake that video. So let's try my best to redo this graph to the best of my ability, and I'm just gonna stop right there. This is my parent graph moved to the left 1/3 and down how much? 13/3. Now, since it's less than 1, I just need to make it bigger, fatter, and I'm gonna use this color. And let's get started. Here we go. So it's gonna look something like this. And how much fatter it is, it really depends on how close it is to 0. This is gonna be fairly close to 0, so it's gonna be big, very big. And we might as well just pretty much figure out what it is. So calculator. 3 times 3 times 3 times 3 divided by 7 divided by 4 divided by 4 divided by 4. Bam. So it's kind of 1/10 or 1/5, pretty close to 1/5. So I think I did a pretty good job doing 1/5, to be honest. Anyways, this is what it's supposed to look like. If you can prove to me that your graph is going to be wider than the parent graph, then you're in business. We're not going to try to get it exactly, especially with a function that looked this bad. That is all. I just want to do this particular problem. You guys have a fantastic day. Bye.